Isochoric process. This is the thermodynamic process. In this thermodynamic process, okay, in which the volume is kept constant, okay, pressure, temperature and internal energy continued to be variables. Okay, only in isochoric process volume is constant and other variables are variables. So after this is the graph, PV graph. In PV graph, okay, in PV graph volume is constant and the in constant case 1 and as well as case 2. Okay, this is pressure final and this is pressure initial, this is pressure initial and this is pressure final. The volume is constant okay, the volume is constant in case 1 as well as case 2. Okay, then if we increase the temperature, okay, but the temperature will increase then pressure also increase that is initial pressure to final pressure. Final pressure, there is no volume change. Volume is unchanged. Remains unchanged. Remains same. When the volume is unchanged, okay, then in case 2 the temperature decreases, pressure this is increase, okay, pressure will increase. If temperature increase then pressure will increase to pressure initial to pressure final. Then in this will decrease. If the temperature decreases, pressure also decreases. Okay, pressure also decreases, but volume is unchanged. Volume is unchanged or remains constant. Okay, this is the isobaric process. In isobaric process, only volume is constant and other variables are variables. That is in initial internal energy, that is pressure, and that is all temperature. Okay, this is the isobaric process. Then cyclic process. Okay, there is we will describe, we will find the um, dimension of we know PV is equal to mu RT, and mu is the number of moles. Okay, mu is equal to number of moles, and R is equal to universal gas constant. T is equal to temperature, P is equal to pressure. P is equal to mu R by V into T. P is directly proportional to temperature. Okay, we find the very important. We find the dimensional. We find the dimensional formula for R. Then PV equal to PV is equal to PV mu RT. Then R is equal to PV divided by mu T. PV by mu T. Then pressure is equal to force per area, that is mL T minus 2. Okay, equal to force, that is per L square, that is m L minus 1 T minus 2. Okay, force pressure is equal to force per, this is minus 2. Okay, this is minus 2, so there is minus 2. Then m L minus 1 T minus 2 V, that is L cube. Okay, number of moles, that is mole. Okay, and T is the theta, temperature is that. Then we find m1 L square T minus 2 mole inverse theta inverse. Okay, this is the dimensional formula for universal gas constant. R is equal to. Okay, this is the universal gas constant, dimension of universal gas constant. Okay, then we find, I will erase this. Look at the blackboard first, and then I will erase. Okay, then cyclic process. When a gas expands from initial state and return to the expands, work done during cyclic process. Okay, let a gas expands from initial state to the final state B. Okay, a system with which return to its initial state, that is called returns to its initial state, that is called cyclic process. Then cyclic process, a process in which the system returns to its initial state, that is called cyclic process. Okay, then work done during cyclic process, work done during cyclic process, the gas expands, let a gas expands from initial state A to final state B. After undergoing the changes of pressure and volume. Okay, then we find the work done. First we draw a graph. Okay, initial state A to final state B. Okay, initial state A to final state B, and then again return to its initial state. Okay, then we draw A, X, B, C, D, A work done. Work done 1, area of, you find work done for, this is the work done. Okay, A to B and B to A, this is the initial state, then first initial state to final state, then it returns to its initial states, that is the cyclic process. Area of A, X, B, C, D, A. Okay, and W2 is equal to minus of area of BY and BYAD CB. BYADCB. Then we find the work done. W is equal to W1 minus W2, that is area of AX BC DA minus area of BYAD CB. Okay, not clearly visible, of BYAD CB. Okay, then what we will get? W1 plus W2, total work done. Okay, W1 plus W2 for negative sign, that is negative. Okay, then we get what? Area of AXBYA. Area of AXBYA. For work done for clockwise, that is positive. work done work done for clockwise positive and work done for anti-clockwise it is negative. Okay, area of loop, we get the area of loop. Area is equal to work done is equal to work done is the area of loop. Okay, we get this. Okay, this is the cyclic process. In isobaric process, another process is there. Isobaric process. In isobaric process, the pressure is constant. Okay, then isobaric process. I will erase this. In isobaric process, pressure remains constant. In this process, in this thermodynamic process, in thermodynamics, isobaric process is a type of thermodynamics process which, okay, pressure remains constant in isobaric process. Isobaric process. In this process, in thermodynamics, isobaric process, okay, pressure is constant. Pressure remains constant in isobaric process. Okay, pressure remains constant. Okay, then del W is equal to del P del V. Okay, change in volume, that is specific volume, final specific volume, P into final specific volume minus initial specific volume. Vf is equal to final specific volume final. Okay, Vf is equal to specific volume final, and Vi is equal to specific volume initial. Okay, then we know from thermodynamics, change of heat is equal to change of internal energy plus work done. Change in work done. So del Q is equal to del U, that is del U plus P into, okay, then del Q is equal to del U this. So initial volume, you can write you can write not initial, that is it is final volume, that is initial volume, or that is final volume, that is initial volume. We can solve another way. In final volume V1 is equal to initial volume. Okay, so we get this value, or you can write y done is equal to integration of p dv. Okay, then p into vi to vf, we will write vf is equal to specific volume final. Okay, vf is equal, or vi is equal to specific volume initial. Okay, then dv. Okay, then w is equal to p del v. Okay, p del v. Then we know w is equal to p into vf minus vi. Okay, then vf is equal to, we can write what we write, pv is equal to nrt. pv is equal to nrt. So we final volume is equal to final temperature, n into r into final temperature, n into r into final temperature, and vi is equal to n into r into initial temperature. So we put this p into nr tf minus nr ti. Okay, then we get pv is equal to nrtf in minus nr, we get, to take common, nrtf minus ti. Okay, then nr ti minus the final temperature and initial temperature, change in temperature, that is change in temperature. Okay, then very f by 2 into w, nr del t, that is f by 2 into w, that is changing, this is changing work done. Okay, or you can write this. Okay, w into f by 2 into nr del t, del w is equal to f by 2, del u is equal to that is u initial change in del u is equal to f by 2 into work done. Del u is f by 2 into nr del t f by 2 nr del t. Instead of w we write nr del t, that is w. Okay, thank you.